Today we learned about direct variation. Okay, let's lock the autofocus. Today we learned about direct variation. You guys have done direct variation before. You did it last year. You called it proportional. Oh, that's not even right. Proportional. Okay. So this year it's kind of like with everything else that we've done this year. We took parallel and perpendicular and we expanded the definition. We're expanding the definition of proportional with direct variation. Okay, so when we talk about a proportional graph or a graph with direct variation, that graph is going to look like a line, a straight line, that goes through the origin. Okay, I'm running out of room. Origin. Okay, now the parent function, it doesn't necessarily have a parent function, but it does have a generic function. We can kind of call it the parent function. It's y equals kx. It's like the y equals mx plus b without the plus b. So it's kind of like y equals mx. And I had somebody in first period ask me, like, well, why don't you just call it y equals mx? And I said, well, why don't you call me your mom? Why don't you call me mommy? And they all looked at me like I was crazy. I said, well, Molly calls me mommy. Y'all call me Mrs. Deal. You call me different things in different situations, so we're going to have different names for this thing here. We also don't call it slope when it's in direct variation. We call it the constant of variation. Sometimes we call it by different names. So this is just the form we use when we're dealing with proportional or direct variation. So like I said, instead of calling this the slope, we call it the constant of variation. It is the slope, but in this situation, we're calling it the constant of variation. Y'all called it constant of proportionality last year. So to find the constant of variation, we take y and we divide it by x. Okay? So let's skip over to this table. If I want to find the constant of variation, this is how I do it, just in case we end up learning, I end up teaching you about inverse variation later in the year. So what I do is I put a k with y divided by x right here. So I kind of extend the table when they give me one. And then I take my calculator and I actually work those values out. So I have negative 10 divided by negative 4, and that gives me 2.5. Well, I'm just going to tell you, they all give us 2.5, except the 0 row, which gives us an error, because anything divided by 0 is undefined. But really, one of the reasons that 0 row is there, that 0 term is there, is to show us that it's going through the origin like we said it was. Okay? So what I'll do is I show what's happening. 2.5 times 2 is 5. 2.5 times 3 is 7.5. That gives me my equation, y equals 2.5x. So if I graph those points, I am going to see I have 0, 0. I'm sorry, I have negative 4, negative 10. I have negative 1, negative 2.5, 0, 0, 2, 5, 3, 7.5. As we graph those points, you start to see that we have a straight line that goes to the origin. It's steeper than the parent function, which we talked about today also. And that's what the graph looks like. Now, we have some key phrases, some phrases that we're going to see almost every time we see direct variation. So one of the phrases we might see is y is directly proportional to x. We might also see y varies directly with x. And the order is important because this is really going to matter for us when we see word problems. So if it's just that they just give us some ordered pairs and say, find me an equation, it's not that hard. We can put them in a table. But when they give me a situation, that's when the order of these key phrases really starts to matter. So let's take a look at a few problems. These are actually problems off of your homework. So the first one says, if y varies directly with x, find the missing value below. So I have negative 836 and 6y. So anytime they tell me y varies directly with x, and they give me a couple ordered pairs, I'm going to make a table, an xy table. Pretty much anytime I do direct variation, I'm going to make an xy table. And then I'm going to put the ordered pairs in there. I have negative 8 as the x, negative 36 as the y. I have 6 as the x, and I don't know what the y is, so instead of putting, a y, I'm going to put a big old box. And I'm going to use that box to figure out what the answer is. Okay, so then I'm going to take my calculator, just like I did before. I'm going to make a k column, which is y over x, kind of extend the table. Okay, So I'm gonna find y divided by x. So negative 36 divided by negative 8 is 4.5. So my k is 4.5. So if they needed me to write an equation, I would write y equals 4.5x. Okay? But since they're asking me to find a missing value, I know 4.5 times negative 8 is negative 36. So 4.5 times 6 is 27. So my missing value is 27 in the question they were asking me to do. Let's try another one. Okay, and this time, instead of asking me for a y, they're asking me to find a missing x value. So same thing, if y varies directly with x, find the missing value below. So I'm going to make another table. Make my xy table. I have 3, negative 39. Oh, I put an x. That was not right. Got all carried away and ahead of myself. Okay, so I'm going to put a box and a 65. So now I'm trying to figure out what x is. Still the same process. I do my k, my y over x column, and then I take negative 39 divided by 3, and I get negative 13. So negative 13 times 3 equals 39. Negative 13 times x is 65. So if I want to figure out what that is, I take 65. Well, I could write an equation. Negative 13x equals 65. Divide both sides by negative 13. 65 divided by negative 13 is negative 5. So my x value is negative 5. So that's how we do it when they just give us ordered pairs. Now, when they give us a situation like this, then we have to kind of figure out what goes where. Now, this one already has them underlined, which is kind of helpful. But what I usually do is I circle varies directly with. And then I underline the two things around it. Because remember, y varies directly with x. Well, now I know what goes in which columns in my table. So I'm going to make a table. But this time, instead of just labeling it x and y, I'm going to put those words there. So x is number correct, and y is, oops, I just did that backwards. Bad Maggie. Oops, let me fix that. X is number correct, and y is my grade. Okay, so you got to be real careful, which I was not, and I apologize for that. Okay, now I look. It says answering 32 questions correctly, because that says 32 correct, will give you a grade of 80. Okay, so if I want to find out, first of all, they're asking me for the constant of variation, so I have to find k, which is y over x. So I'm going to add that column. I'm going to do 80 divided by 32, and I get 2.5. So my constant of variation is 2.5, which means my equation is y equals 2.5x. So now it asks me a question. How many questions do you need to answer correctly to get a grade of 90? So grade is my y value. So my grade of 90, I have 2.5 times something equals 90. Well, 90 divided by 2.5 is 36. So I need to get 36 questions right. Okay. Now the last question is really not, it doesn't have any underlining. They didn't give us any hints. We're going to have to actually just completely figure this one out ourselves. Okay. So it says the power, P, of a gear varies directly with the radius, R, of a gear. So I'm going to circle varies directly with, and I'm going to underline the stuff in front of it. Okay. Now this one's tricky because they already gave me variables. So I have y and x. So when I make my table, I'm going to put y here and x here. But I'm going to say power, P, and I'm going to say radius, R. I'm going to use the variables they gave me because they're referring to those words and those variables. So they're referring to radius and power in this part of the question. Here, they're referring to those letter variable values. So I need to know, I have to be able to keep all of that in track. Did I just do that? Did you guys notice that? Okay, I gotta fix this table. Let me fix it again. Did y'all see what I did there? instead of putting my x first, I put my y first. It's so easy to make mistakes on this. Okay, so x, then y. Okay, x is radius, r, and y is power, p. Oops, I'm sorry about that, y'all. But I'm glad I caught it before I saved this and uploaded it. Anyway, that's neither here nor there. Okay, so it says P is 300 when R is 50. So if I'm going to write an equation, I got to find K, which is y over x. So 300 divided by 50 is 6. So my K value is 6, so I have y equals 6x, or more appropriately, P equals 6R. Because remember, they've got variables. They've already got variables. This is what you would see in an answer choice, even though this is kind of how we would think of it. So sometimes you guys ask, do I have to use those letters? You kind of do. Okay, so now let's look at this one. It says find the radius of a gear that has a power of 510. So 6 times something equals 510. Well, 510 divided by 6 is 85. So the radius is 85. And that's the answer to our problem.